Agwinarisha, Akorja, welcome back to the fourth day of IST-Africa 2022. And my name is Paul Cunningham. Following a very interesting discussion by Daniel on open science policy in South Africa, we're now starting the TEL or Technology Enhanced sessions today. And our first presentation is from Gerald, who's going to discuss equitable access to e-learning during the COVID-19 pandemic and beyond, a comparative analysis between rural and urban schools in Zimbabwe.
Good day, viewers. I would like to firstly acknowledge this opportunity which has been presented by IST-Africa. I'm here to present my topic, Equitable Access to e-learning during COVID-19 pandemic and beyond, a comparative analysis between rural and urban schools in Zimbabwe. My name is Gerald, Tsimba, a PhD student at Nelson Mandela University in South Africa. And the authors of this paper includes Beauty Mukoniwa and Amanda Mutembedza, who happen to be the lecturers at Midlands State University in Zimbabwe. The study was motivated due to the increased adoption of e-learning platforms, especially, or it was exacerbated by the advent of COVID-19 in the past few years, which led to some marginalized schools failing to access the e-learning capabilities during that time, in the height of the COVID pandemic, which also exacerbated an increased digital gap between an urban and a rural learner. The objectives of this study became, number one, to determine the preparedness of rural primary and secondary schools in adopting e-learning, to analyze the e-learning resource equitability between urban and rural learners during the COVID-19 pandemic, as well as to establish challenges currently being faced by rural schools in the adoption of e-learning during COVID-19 pandemic. And one of the primary objective was to profile an e-learning adoption strategy for classroom delivery in rural schools during national crisis and beyond. So the study pursued mixed research methodology, which included both qualitative and quantitative analysis, right? Based on the pragmatic research paradigm, the study pursued a case study strategy based on 23 rural and urban schools located in Koromozi district, Mashonaland, and East Province of Zimbabwe. Ethnography was also pursued as a qualitative method in between the period 2020 and 2021. And part of the quantitative method, the study pursued a survey targeting 112 participants, which included school administrators, teachers, and parents. Within the findings of the study, which is also in tandem with the research objective provided in trying to figure out the e-learning preparedness in rural schools in Zimbabwe, right? The study found out that most parents in rural school environments, they were not learning savvy, which also negatively contributed to the adoption of e-learning during the COVID pandemic period, as well as the lack of e-learning devices within that learning environment in rural schools, which also led to reluctancy from parents in the way of making follow-ups in homeworks which were provided by teachers, as well as the inability in terms of accessing e-learning software due to high cost and network challenges, which also impacted negatively in the picture of preparedness of rural schools in adopting e-learning during these dangerous and unfortunate times. However, both primary and rural school learners experienced high data costs is also a negative impact attributed by the deteriorating economic environment nationally, even globally. Another objective was to testing or analyzing the e-learning accessibility and equitability between the rural learners and urban learners. So the study went on to test using the unequal variance between these two types of learners using a t-test, which is also an inferential statistical analysis tools, right? Also, the study used the 6 observations, which included computer literacy within teachers and parents, access to electricity or power supply, availability of e-learning devices, ability to purchase periodic data bundles, strong internet connectivity, access to e-learning software. So within this observation, the study observed with 95% confidence that there was a significant difference in e-learning access between rural schools and urban schools, which also suggests that there was quite a difference in accessing and adopting e-learning between rural school learners and urban school learners. And this was at the disadvantage of rural or marginalized school learning environment. So moving on to the challenges in the adoption of e-learning during this COVID-19 pandemic, the study also observed that unlike urban school learners, parents, rural schools were less parents, so rural school parents were less supportive to e-learning environment due to the fact that they did not have even those devices. The environment was not electrified. And as I said earlier on, they were not savvy to the e-learning programs. And there were quite some challenges, as mentioned before, and which also left these students in an environment where they could not learn and just wait for the schools to be opened. So it was very difficult for both the teachers, the school administration, even for the parents themselves to monitor the e-learning performance of their children, because some of them, they do not have, as mentioned earlier, devices. Whilst the government provided e-learning policies, however, no meaningful resources were provided in terms of computing resources, financial resources to support the learners to be in the classrooms or away from school, right? So which also led to a high reluctance within the learning environment in the rural schools. At the same time, due to economic challenges, both the teacher and learner, both in rural and urban schools, they were impacted economically. So they could not afford to buy these devices or the much needed e-learning devices to pursue this learning environment. The study went on to propose an e-learning strategy based on the challenges, based on the learning environment during such kind of pandemic periods, right? So basing the e-learning strategy, the objectives, setting objectives to the e-learning environment assessment of e-learning, strategy formulation, strategy implementation, strategy control. This was borrowed from the strategic management principles in setting up strategies. So basically the Ministry of Education and private players are the ones which are expected to support this e-learning environment, as they are the financiers, they are the policymakers, especially the government, whilst the private players come in to support financial and resources. But for this to work out, there is also need to, in accordance to those pillars, there's also need to capacitate teachers in terms of devices, the same as the learners. They also need to be capacitated with the knowledge of e-learning platforms and devices. There's also need to invest in infrastructure, which notably the study identified the inclusion of, or the introduction of ICT hubs so that they can cater for a cluster of schools, at least 2, 5, etc., depending on the geographical location of these schools. There's also need to involve parents in terms of teaching them, in terms of highlighting on how the usage of e-learning resources, also involving them in e-learning decision making. The schools also should make up e-learning policies and how they are going to conduct e-learning, not just be part of e-learning without a proper framework in adopting that, which also leads to the fact that the learning environment should also encompass the classroom delivery methods. After this capacitation, or after these pillars have been met, the learning environment should be based on print media for those who cannot access e-learning resources. There should be textbook, hard copy printouts, etc. They should also be in conjunction with online lessons for those who can. The government and also private players who can also intervene with radio and television media to support this platform, which also lead to the global educational goal SDG 4, which also caters for everyone and free and access to education. Right. However, apart from this framework, we also noted that there also exist barriers to equitable access of e-learning delivery. So as you go forward, or as you try to strengthen these pillars, we also need to note that the adoption of e-learning strategies to also make sure that it gives attention to those barriers and meet them with appropriate measures so that the global educational goal within the learning setup is met, right? Then moving on to the conclusion of this study. The study in background, the study aimed to determine the increasing digital disparity between rural and urban learners in Zimbabwe. So in conclusion, the findings suggest that there is an equitable access to e-learning between rural and urban learner. The most affected learner is the rural learner. Therefore, the study has also proposed an e-learning adoption strategy to ensure that e-learning adoption do not further marginalize rural learner during and beyond global crisis, and also nip the bud of digital disparity between the rural and urban learner. The study also recommends the construction of ICT hubs for rural cluster schools, and also adopt green energy, like solar energy, which might be cheaper than waiting for the government to connect schools to the electricity grid, which has become a nightmare for these marginalized learning environment. There's also an importance of incentivizing learners, which is also crucial, looking at the private players and the government itself, so that these learners, they should not be disadvantaged. There's also an alternative learning opportunities that require less or no technology. For example, as we mentioned earlier, the issue of print media, they should be maximum distribution of textbooks, maximum distribution of printouts, handouts, so that this learning happen even during these difficult times where there's no network, where there's no devices, right? So there's also a consideration which should be taken into which includes training parents and involving parents in the e-learning process so that they can be part of learning or teaching in these kind of environments where teachers, they will be physically away from the learners. This brings us to the end of this presentation. I would like to thank you viewers for this time, and also again thanking IST-Africa for this opportunity. This is the end of this presentation. Thank you all. Thank you.
Thanks very much, Gerald. I think the challenges for rural and traditionally disadvantaged communities, wherever they might be, are something that's important for all of us to consider. So I can see that Sheila has a question, and then I'll call on Jay. Sheila, can you unmute yourself?
Thank you, Gerald, for that presentation. My question was that we acknowledge the increase in the use of the e-learning platforms during the pandemic period. But now, how do you compare the situation in 2020 and then 2022, given the fact that COVID is subsiding? That was my question.
Oh, can I come in? Do you hear me?
Yes.
Oh, fine. Thank you very much, IST, for this opportunity. The situation, Sheila, is still, can I just say, it's still the same. The challenge is still the same, and we still have the same challenge. And I hope I happen to be a teacher in that in that period, and I don't see any change. COVID is still there, it's among us. But the rural schools or the marginalized schools are still experiencing the same scenario. Let's say even the fourth wave forces the schools to shut down in the near coming future or days. It also means that we are going back to square one, where the same situation is being experienced. As I said earlier on through that presentation, that there are not even resources to support e-learning. So rural learners, they tend just to sit at home. Parents relax, teachers, they relax because there's no way they can proceed. So there is, in a summary, there is no change. And 2020 is still the same as 2022. Whilst the government, as I said earlier on, has got policies on e-learning. They just say in policies that schools, they should continue doing online lessons even after the much hyped COVID period, but still it's just imaginary in as far as we can talk about the rural learning environment. Thank you. I hope you've been answered.
Yeah, thank you so much.
All right.
Thanks, Gerald. Thanks, Sheila. Jay, your question?
Thank you. Thank you for the presentation. I just wanted to ask the presenter on how ready is Zimbabwe government is ready to implement the proposed framework in terms of maybe implementation, adoption first, and implementation. How is the government ready?
Sorry, you're breaking. I can't hear you. Can you please repeat the question?
So,
are you? Yes, go ahead, please.
So Jay was asking, how ready is the government to deal with this situation? To adapt and implement the proposed framework that you're talking about?
By the virtue that all schools, nearly every school has got a school-based policy. on the adoption of e-learning. I think that is the start of the readiness of the government, because it's recognized by the government that all schools, they should partake in e-learning even after this COVID environment. So it's now part of the learning system, apart from physical delivery learning environment. So by that virtue, that it's now part of the system, and it's now part of the educational policy that e-learning should be done even during holidays. I think that's the first step of the readiness of the government. Whilst also not short to say that there is not much in terms of actual work, in terms of support, like devices, like even bringing in private players. I remember when the COVID started, I think it was in 2021. Sorry, it started earlier, of course, but it was in 2021. Still one partnered with Ministry of Primary and Secondary School to introduce an e-learning platform known as Impact Learning. But it did not go, it was supported by the government, of course, but it did not go as far as it was supposed to be because of lack of funding or support. I don't know how the administrative issues went on, but it was just silent after that. Then I think in 2021, UNICEF partnered with Microsoft in provision of an e-learning platform known as Learning Passport, and as well partnering with the Ministry of Primary and Secondary School Education. Initially, it was targeting refugees in provision of learning, online learning environments, but of course, because of COVID environment, it also catered for all learning environments, primary, secondary school learners, even up to university levels. Well, as I was part of the system, yes, they came in, but from my experience and from my ethnography experience or exposure, I did not see much benefit to the rural learning environment. Whilst I say the government, by just introducing and also partnering with these organizations or international organizations, is part of the process towards the adoption of maybe a framework whereby we are saying from the base of the platform, there should be clear strategy formulation, and as well as involving private players as we go upwards to strengthen those pillars. We need to incentivize teachers. We need to, they need to incentivize teachers. They need to incentivize learners. They need to educate parents, right? Whilst this is still yet to be achieved, but I feel it can be achieved as we go forward. The most important thing is to involve private players who are the financiers, because the government itself has proved for quite some years that it's incapacitated in form of supporting the education system. So I think the involvement of private players from the government side, as they are the policymakers, will make it happen.
Thanks, Gerald. And Martin, you had a comment.
All right, thank you. Derek, thank you for the presentation. The framework you came up with was a great framework at resolving that problem of especially the rural areas where electrification and internet is a problem, especially if you take the telecos, trying to reach the rural areas where they feel their return on investment usually isn't good enough for them to reach the rural areas. Internet is a challenge and it affects e-learning implementation. So in terms of the hybrid approach that you indicated in your framework, is a very good one, considering that radios may reach further than internet is reaching currently in some rural areas. And then even without electricity, people could still power their radios on batteries, and then even solar, smaller solar panels, movable ones. But the challenge with that also is if e-learning will have to be carried out by individual schools according to their timetables, then you see there will be a choke up on the radio stations and then TV stations. So possibly maybe in future research, if you could look at reclassifying the hybrid approach in terms of the TV and radio stations should be more of a national level thing. So at a particular time when a particular subject is taking place, it isn't tied to a specific school, but it's a national thing that let's say maybe stage 4 or class 4 program is running. So throughout the entire country, nationally, all the students in that particular class can actually listen to. But if it is not done nationally, and individual schools will have to go on radio stations and TV stations, that creates another problem in terms of the TV stations and radio stations can't handle all of them. So maybe for future research, maybe you should consider maybe re-looking at that hybrid approach, maybe reclassifying it to be more of a national level hybrid approach instead of individual schools approach. Or if that is how you actually did it, maybe you can explain further for us to understand. Well, my understanding currently is you're talking of a hybrid approach, but at individual school levels. Thank you.
Thank you, thank you. That's quite a noble contribution. Thank you for that one. I think, yes, that's true. And I understand where you're coming from. That's very important. And I also want to reinforce on that one. Part of my recommendation as well was also to, for schools, to incorporate cluster-based ICT hubs, because solely relying on the government and their provision of electricity or connecting these schools, because there are some schools in this age, especially in rural schools, they're yet to be connected to the electricity grid. So there is not even much of a dream to think about e-learning. So one of my recommendation to support that one, there are some schools as well, even adopting the hybrid approach. There are some school learners who cannot even access the radios because they don't have the online issue, they don't have the network, they don't have the power supply, they don't have the access to print media as well. But if schools, they bring in players or themselves, they contribute to just create one school which is up to date in terms of ICT facilities using the solar energy, which may be cheaper. And that school may be a central hub, maybe serving other 10 schools, or depending on the cluster and the geographical vicinity of other schools. That will also may also bring in to support the much needed learning. And it becomes the center of ICT learning. For those who cannot access the radios, those who cannot access the TVs or internet. So that school may also be wired to the internet, or just make use of the computers and e-learning installed resources. Thank you very much for that contribution.
It's a pleasure. Thank you also.
Thank you.
Thanks, Martin. Thanks, Gerald. That was very interesting. I think, you know, apart from the fact that you've highlighted that it's a basic infrastructure challenge, I would have suggested considering looking at using TV white space type use of available bandwidth as a way of reducing costs. But maybe that's something that could be considered after some of the more basic infrastructure issues have been raised. So thank you very much for this contribution. So the next presentation is focused again around the impact of COVID-19, but maybe from a slightly different perspective. Constructivist learning during the COVID-19 pandemic, teaching and assessment skills in postgraduate certificate of education students.
My name is Tafirenyika Mafugu. I am from the University of Free State in South Africa. My research focus is on science education. And in today's topic, I am going to present on participatory learning during the COVID-19 pandemic, teaching and assessment skills in postgraduate certificate of education students. This is the structure of my presentation. I will focus on the statement of the problem, research objectives, research hypotheses, the methods, results, and conclusions. Let me now focus on my problem. Peer assessment has been integrated as a strategy to promote student learning in higher education. However, little has been studied about how students at different learning levels may benefit from peer assessment. Furthermore, the accuracy of peer ratings compared to lecturer ratings is a major concern for both lecturers and researchers. The concern has grown with the increase of peer assessment in the digital platforms after the onset of the COVID-19 pandemic. The objectives of the study: to explore the effect of online peer presentations on the development of pedagogical skills, to determine the difference between peer and lecturer assessment scores during the online group presentations and assessment by pre-service teachers. Research hypothesis. The study sought to answer the following hypothesis. There was no significant difference in marks between peer assessment marks and lecturer moderated marks among pre-service teachers taking the post-graduate certificate in education science course. The research methodology. The study was supported by the survey research design. 40 students in the PGCE science methodology course were taught various aspects of constructivism in line with teaching, which means they were taught how to apply the various aspects of constructivism in their teaching. A number of examples were taught. In addition to that, there was teaching in line with the lesson development process from introduction, the body, and conclusion. And the students were able to see that the lesson development process it may vary according to different situations. The students were also exposed to questions of different cognitive levels according to Bloom's taxonomy, so that they get the sense of how they can set questions of different cognitive levels, including low order and higher order questions to develop critical thinking skills. A number of questions were given to illustrate the questions that fall into different cognitive levels. Students were also taught on the use of the Blackboard Collaborate. They also learned how to upload the PowerPoint presentations and how to make recordings and download the recorded audios. The assessment rubric was reviewed by experts to ensure that when different individuals use the rubric for assessment in an objective way, they will come up with the same outcome. To assist students in developing the evaluation skills, there were 2 recordings that were presented in class, and all students were asked to allocate marks for the presentations, and then this was followed by a discussion where there was agreement on the final mark that should be accorded to each of the 2 students according to the aspects of the presentation. Students were then put in groups of 5, and then they had to present to each other using the Blackboard platform, and as one student present, the other 4 had to evaluate. And the rubric had 5 aspects. Each aspect had to be assessed out of 10. As a result, these 4 students who assessed the presenter had to, each of them had to give a mark out of 50. After the assessment process, the students had to upload their marks on the Blackboard platform for moderation by the lecturer. And the lecturer also had to record the marks. So the average peer marks as well as the lecturer marks were then recorded, and these were used in the comparison process. In addition to the marks, the students also had to complete a Google Forms survey, which had 3 variables where students had to rate on a 5-point scale from strongly agree to strongly disagree. Students had to evaluate the effectiveness of group presentations, group assessment, and feedback in enhancing the pedagogical and assessment skills. They had to complete the Google form during the last few days of their teaching practice. The marks for the peer and the lecturer were uploaded on SPSS, and then a lot of calculations or computations were done. The Kolmogorov-Smirnov test and Shapiro-Wilk test was used to check if the dataset met the normality condition, but it was observed that the normality condition was not met, and hence non-parametric Wilcoxon signed rank test was used in the comparison of mean scores. All the tests were carried out at 5% significant levels. Furthermore, descriptive statistics, the mean, standard deviation, mean rank, minimum, and maximum percentiles were obtained. These were the results from the Google form that was sent to evaluate the effectiveness of group presentations. We can see that on the issue of online group, on the usefulness of online presentations in improving pedagogical skills, students generally agreed that these online group presentations were useful in enhancing their pedagogical skills. And when it comes to assessments practices, we can see that most of the students agreed that the online group presentations were useful in enhancing their assessment strategies. Finally, we can see that the students generally agreed that the online group presentations were useful in developing their pedagogical skills as well as improving their assessment skills during the teaching practice period. And the results for the peer marks and lecturer moderated marks indicate that the peer marks had a mean value of 33.89. The lecturer moderated marks, the mean value was 30, which means the lecturer moderated marks were lower than the peer moderated marks. And to check whether this difference was significant or not, initially there was anomaly test, which was conducted using Komogorov, Smirnov, and Shapiro-Wilk test, and both tests indicated that the data sets were not normally distributed, and hence the non-parametric test was used to compare the means. And in the comparison, it was also noted that the difference was significant, emanating from a small p-value, which is less than 0.05. Conclusions. Moderation of the marks by a lecturer is necessary to ensure that students develop the attributes of thoroughness and honesty, because we observed a significant difference between lecturer and peer marks. Peer learning and assessment are recommended in teacher training courses, and they promote attainment of the pedagogical skills. Online presentations and peer assessments play an essential role in preparing students for teaching practice. However, the students learned a lot from the presentation, despite the significant difference between the moderated marks of the peers and the lecturers' marks. There is need for further studies on peer assessment involving many students from various institutions around the world to gain insights that can be generalized about peer learning and assessment. And there's also need to come up with a strategy that where the peer marks can actually be enhanced so that they actually match the marks for the lecturer. So there is need to come up with a model that can be used to enhance this development of assessment skills. That is the end of my presentation. Thank you for listening.
Thank you very much. Can you talk us through what you think some of the most important implications of your study are, and how they could be generalized in an African context where many countries might be sharing some of the same challenges, and how that might offer opportunities for strengthening cross-border collaboration in this space?
Thank you very much. I think the results can actually results of the study can be important in many situations. For example, where we have large classes, it might not be possible to assess all the students effectively. So if this peer assessment could be implemented, and if students are honesty, then the peer assessment can actually assist in the assessment process. But as they assess each other, it is the most important aspect is not to get the marks, but to learn various aspects. So when students present to each other, they learn from each other. And the other advantage of peer assessment is that when one doesn't perform well in the presentation, the person will have other opportunities to present again to the same members until they finalize the marks. So the important issue is to develop the skills among themselves. But it is also important to note that because of some form of dishonesty that students can have, it is important to record the presentations and then moderate to ensure that they develop the required skills. And after moderation, it is also important to have a class discussion and discuss some of the important issues that the students have to take note of. I think the issue can actually be important in developing both theoretical skills as well as science practical skills in cases where there are large classes. Thank you very much.
Thanks for that. I find this interesting, but also challenging. So I think it depends on the context. I was at a meeting in San Diego recently where one of the awardees at an IEEE ceremony made the point that one of the best ways that he found of getting better at what he was doing was to teach it. And he was involved in a movement that involved students helping other students to better understand technical issues. And that made a lot of sense to me based on my own experience of teaching from the age of 11 in a different field. But obviously you mentioned gaming the system, you mentioned the opportunities for potential dishonesty. So it's kind of balancing the strengths of using this as a teaching moment that strengthens the capacity and the understanding and the ability to communicate complex ideas. Because if you can communicate complex ideas, you have a better understanding of them, which strengthens your own expertise and your own knowledge, which is obviously important for a student. You could also, however, have a situation where either people could coordinate that if I give you a good score, you give me a good score, or in a situation where there are in certain educational contexts, a concept called grading on a curve, where so many people get an A, so many people get a B, and so on and so on. So there are those kind of negative incentives for dishonest behavior. So in an African context, how do you see that working in practice? And if anybody else has any comments based on their own educational system, perhaps you could mention that in chat and I'll call on you.
I think what I've actually highlighted is that those aspects that you highlighted, the aspects of dishonest, they are actually possible, the way students can actually negotiate marks. But to eliminate that aspect, there is need to do random moderation. So if there is a group of 5 students, they will have uploaded their presentations, so you can randomly pick one from those 5, and when you randomly pick one, you moderate and actually find out if there was this form of dishonest or not. So I think the moderation is a way of checking with this issue of dishonesty, and to ensure that the students do not get exaggerated marks.
That's fine. Thank you very much. So our last presentation this session before the break is from Nesisa, and it's focused on Mask Up, a face mask alert app using machine learning.
Hello, my name is Nesisa Moyo, and I'll be presenting the paper titled Mask Up, a face mask alert app using machine learning. This paper has been cohorted alongside Swanile Moyo and Belinda Mutunu from the National University of Science and Technology. I am currently a teaching assistant in the Department of Computer Science at the National University of Science and Technology, where I teach both second year and final year students programming in Java and Ara languages. The primary motivation for this work is from the fact that the COVID-19 pandemic has been a challenge for the past 2 years and continues to be so, with the virus showing more mutations with time. The use of face masks in public spaces has been proven as a precautionary measure to minimize the spread of the coronavirus, which is a causative agent of the disease. However, enforcing the proper wearing of masks, particularly in environments like schools, is a daunting task. Studies show that the use of a face mask is effective if worn over the nose and mouth by both the infected and non-infected persons. The research objectives were aimed at identifying the components of an application that can alert teachers if students are either wearing face masks or are not wearing them correctly. With these components in this research, we seeked to create a dataset of images of people properly wearing and those not wearing face masks. Train an adapted machine learning model to classify the images. Send an alert WhatsApp message with a screenshot image of people not properly wearing and those not wearing face masks to the class manager and evaluate the developed machine learning model for its effectiveness and efficiency. Our research approach used the build methodology as follows. We use the build methodology as the overarching guide for building the proposed maskup application. We view this method as appropriate for the task as it enables us to systematically explore the application requirements. At the implementation stage of the research, we adopt the personal software process, PSP, to build quality into the modules of the application. We expound on the design in the following subsections. Applying the build methodology to design maskup. Following closely the stages of the build methodology of investigation, setting of objectives, design, development, and the demonstration phases, we built the app as follows. During the investigation phase, the authors explored several machine learning models and datasets that could be used for designing the target model. 2 convolutional neural networks, CNNs, were considered as candidates for implementing the machine learning model. And these were You Only Look Once version 3 and MobileNet version 2. These 2 were compared using a dataset identified from Kaggle. The experiment used an images dataset from Kaggle and images of the first author, myself, of properly worn mask and improperly worn mask. The 2 CNNs were compared using the dataset. The objectives of the research were set as discussed above. We then adapted the machine learning model using PSP. Maskup application was designed and developed using personal software process, PSP, as the chosen model. PSP was used as it enables the development of quality software. Here we show how we used PSP to develop the maskup application. PSP as a methodology guides the developer in estimating, planning the development work, tracking performance against these plans, and how to improve the quality of the product to be produced. And we did all this using PSP. PSP is recommended in this project because its goal is to produce a zero defect product on time and within budget. As shown by the figure, PSP was used to guide the design and development of the model as follows. First, data collection. A dataset of people properly wearing and those not wearing face mask from Kaggle together with the face images of the first author were collected. Secondly, pre-processing and training. At this stage, the dataset was loaded to a high computer graphics processing unit environment. This was done because the machine learning process is computationally expensive and carrying out training on a central processing unit might have taken a longer time. After loading the image dataset, the processing was done. This was done using TensorFlow and Keras algorithms. The 2 algorithms were used to classify the images as mask and no mask. After classifying the images, a plot of the model was made and the face mask detector model was saved as an H5 file. An H5 file is a TensorFlow data file that stores the machine learning model. The results were a fully functional application maskup. On detecting an improper mask-wearing face or a face with no mask, the system displays a red message, no mask, while a face with a mask properly worn is flagged with a green message, mask. To enforce the proper wearing of mask on detecting persons improperly wearing masks, the system automatically sends an alert WhatsApp message to the classroom manager, the teacher, to take appropriate action. The software prototype uses Python's libraries such as Keras, TensorFlow, MobileNet version 2, and OpenCV for computer vision. An alarm sound was created using Python's WinSound imported library, and SQLite database was used to save images of people detected not properly wearing a mask or not wearing a mask. This is how MaskUp app functions. It is able to detect proper wearing of face mask, mask covering mouth and nose. Also, it detects improper wearing of face mask, mask partially covering mouth and nose, and students not wearing face masks. Upon detection of all that, if students are not properly wearing their mask and if they're not wearing their face mask, it captures a screenshot image of a person not wearing and improperly wearing a mask and save the images in the systems database. It then uploads data in the systems database server in 2-second intervals, then sends an alert WhatsApp message with a latency of no greater than 1 minute from the moment students not properly wearing mask and not wearing mask are detected. It maintains a real-time live video camera. As shown by the figure, still on result, it shows how the video camera detecting a face not wearing or not properly wearing a mask, and the classroom manager is alerted of these instances. So on real-time live video camera, upon detection of a student not wearing their mask, the application captures a screenshot with the red message, no mask, and sends a WhatsApp message to the teacher immediately to alert them that a student is trying to enter the classroom while he's not wearing their mask. Sending this message to the teacher's WhatsApp, and it has the alert message, MaskUp app alert, student is entering without a face mask, see in camera to recognize student, please advise to mask up. So it does the same for a student who is not properly wearing a mask. It sends an alert message as well upon detection of that. As you can see from this image, the student is just covering their mouth. They are not covering their nose. So that is improperly wearing of a face mask. So the teacher is alerted of this instance as well. So SMS messaging is used in the event of the network unavailability. So if the teacher is offline on WhatsApp in terms of network, they still receive an SMS alert message. Evaluation of the model shows 98% accuracy. We conclude by saying that we consider the MaskUp application to be an innovative solution towards possibly reducing the spread of COVID-19 pandemic in schools. The application removes the burden of constantly checking on pupils from the teacher to the technology, hence consistency and effectiveness. Further, reduction in infection in schools minimizes the need for school closures that would have a negative impact on the children and the economy. Apart from its use as preventative measure against the COVID-19 pandemic, MaskUp application will be of use in any environment where masks are recommended as a form of protection. And it is almost every today that we need to be wearing our face masks everywhere we go when we leave the house. And we can still implement MaskUp application in different places that require us to wear our face mask. Examples of such environments include the mining industry, agriculture, and hospitals, just to name a few. Enforcement of mask wearing through such technology in these environments would help businesses cut down on the expenses associated with claims from employees that are health related. For maximum effectiveness, we recommend implementing the model in a live classroom setting where a number of cameras are placed strategically to access the whole class. This enables continuous identification of students violating the set mask conditions. As further research, an empirical study could be done to determine the perception of teachers on the usefulness of such technology through the use of models such as technology acceptance model. Thank you.
Thank you very much. What feedback do you have to share in terms of the perceived impact of mask wearing on the education process? And we have a question from Chipo as well. So Chipo, do you want to start off?
Thank you, Paul. It's not a question. Actually, I was just responding to your comment that does anyone have an experience they could share on mask wearing? And I've just typed that the experience I had was the impact it had on one of my students who had a hearing impairment and was thoroughly relying on lip reading. And the fact that throughout the semester, as a lecturer, I had to wear a mask impacted him negatively. Over.
That's very interesting. So how did you overcome that? Did you have to spend extra time with the student out of class? Or did you have to take off your mask from time to time? Or did you use chat functions? How did you overcome that barrier?
Okay, in my case, I was using notes. I would give him notes from what I had experienced in class. And one of my colleagues who was also having the student in class said, okay, they are hearing the mask, and from the two of us, you could see that we had different solutions. Over.
That's very helpful. Thank you very much. Martin, you had a different issue you wanted to raise.
Yes,
and then I'll call on Katasto. I'm sorry, I didn't see that you'd already commented.
Okay, I have two questions. The first one has to do with the quality of image loss, especially when it's transferred between devices. So I'm looking at the time that the images or the videos are transferred from the application server to the class manager's device. In case there's some loss in the quality of the image, whether if during the testing of the application, whether there were some false results because there's loss in quality, especially where inappropriate wearing of marks. Probably the loss in quality could have made it look like a marks is worn inappropriately, whereas it's worn appropriately. Whether if that was observed during the testing phase and how that was handled or any provisions made to handle that. Then my second question had to do with the issue of ethics and privacy. Recording the students in terms of how does the application notify them to get their consent because of privacy issues without their consent, recording them, especially when a third party gets access to these images or videos, it could become an issue. How was that also handled? Does the application in a way, I'm not too sure. I'm just on to find out whether that was taken care of during the development or if it will be taken care of in future research. Thank you.
Okay, thank you so much. Can you hear me?
Loud and clear.
Okay, so from the first question about receiving any false positives, initially, yes, false positives were received in the fact that there were detection problems, the system not being able to detect accurately. But to improve this, more images were added to the dataset. Initially, the dataset consisted of 900 images, 450 with the classification of people with their mask on, and the other 450 with the classification of people not properly wearing, included with people who are not wearing their face masks. So more images were added, which resulted in 1,400 images belonging to the two classes, the with mask with 700 images and those without a mask with 700 images. So that is how the accuracy of the model was then improved for it to no longer acquire false positives. And then for the other metrics that you mentioned, thank you so much for that suggestion. I had not looked on that, but most definitely would try to incorporate that. And then, thank you so much. And then the next question on privacy concerns, the system prototype was that we did testing in a simulated classroom environment, and it's currently in the testing phase, so it hasn't been implemented. But with terms of private concerns, we look to liaise with the Ministry of Education on privacy concerns, that if we reach out to them, there'll be a part which includes people not having to be worried with having their images being captured. If they agree with that, then we go forward to implementing the system in schools.
Thank you.
Thanks very much. David?
So thank you. So that's a topic, a field of interest that I really like, because I used to do that in astronomy. So my first question is, as I assume that you must have some false positive, for example, people classified as not wearing a mask, but they were actually wearing a mask. So do you have some of these like examples, and why could this happen? And another question is, for accuracy, sometimes if your data set is kind of unbalanced, it can be misleading. So maybe, I don't know if you try to use some of the scores, for example, the record precision F1 score. And maybe one thing that I would recommend is to use a confusion matrix, so that you can see how much false positive and false negative you have. But I'm really interested to know if you have some false positive and what are these.
Okay, thank you so much. So in terms of the false positives, we used a convolutional neural network, MobileNet v2, which unlike the other methods, it can automatically, it was used as the classifier to classify that this object is a face of a person, or it's a car, or it's a face mask. So for the face mask, the convolutional neural network MobileNet was used to identify the face masks by applying landmarks, marking points showing the face mask part, and then that was used to classify that this is a face mask. So the algorithm automatically detects that. That's what was used to avoid such false positives.
Thanks for that. And Katasu? Sorry, Katasu, can you turn up the volume on your mic or get closer to your mic? We can barely hear you.
Can you hear me now?
It's better, thank you.
Okay. So I think that
no, it's bad again. Again, can you try going closer to the mic? Or why don't I read out the question, and then if you want to comment after Nesisa answers. What were the perceptions of the teachers regarding the app? Were the WhatsApp notifications only coming in when students enter the class, or also during the lesson? Were the students consulted and informed about the app? Thank you.
Okay, thank you so much. From where we tested it, the teachers liked the application, the idea, and then I didn't get the second part of the question. Please kindly repeat that. Thank you.
problem. So were the WhatsApp notifications only triggered when the students entered the classroom, or if somebody took off their mask or took it off their nose, for example, did it trigger during the lesson? Were the students consulted and informed about the use of the app?
Only when a student is not wearing their mask or improperly wearing their mask, that's when the WhatsApp message is sent to the teacher upon entrance. This was placed, the real-time live video camera was placed in the entrance part of the classroom. So only the alert message was sent when a student is not wearing their mask or improperly wearing their mask, and students were notified of this.
And did you get any feedback from teachers in terms of perhaps the students put the mask on properly, or they put it over their nose, for example, when they received the WhatsApp message but coming in, but then during the class, you know, due to the number of people in the room, perhaps they moved it off to make it easier to breathe. Did you get any feedback from teachers in terms of what behavior happened after they were sitting in the classroom?
Yes, during class, it will still be sending the notifications if a student is detected without their mask or not properly wearing their mask, because where we tested, there was like a teaching assistant who would also be receiving those notifications and helping the teacher.
That's great. Thank you very much. So does anybody else have any questions or comments based on the session before we take a short break? Right, I can see there might be, yes, so Katazo responded that she thinks most of her issues have been answered, so thanks very much. So the next session is going to start after the break, so we're going to start again at 1:15, and we have presentations from Tanzania, Ghana, Namibia, and South Africa. So have a short break, check your mail, have a coffee or a tea, walk around, and we'll see you in 15 minutes.